Hello, hello! Alright, let's continue our learning on exponentials. Today we're talking about exponential growth. So, I've mentioned that there's two. There's a growth and there's a decay when something is, increasing over time, or decay being where something is decreasing over time. We'll talk about decay tomorrow. So growth again is like words where we see increasing, getting larger, growth, it's rising, anything like that tells us this is an exponential growth. So as x increases for growth, that means y also is increasing. So as x increases, y increases. Let's remember that on a graph, a growth looks like this. So as we're going through time, for example, my y value would also be increasing. So as we move this way, my y value is also going up. So that is growth. For exponential growth, my multiplier must be bigger than 1, bigger or greater than. Again, because we're getting larger, so my number should be growing, and the only way my y value would be growing is I'm multiplying by something that's greater than 1. So like if I have a multiplier of 2 or even 1.21, both of those are greater than 1, and therefore you would have some sort of growth happening. Now there is an equation that we're going to use to help us. So when increasing by a percentage, so if I tell you cost is increasing by 20%, okay, we have to do something to that to change it into a multiplier. So when I give you a percent, we add it to 1 to create our multiplier. So in our regular equation where we have a times b to the x, in order to get that b value, if it's a problem where I'm telling you we're growing by a certain percentage, you need to take that and add it to 1. So you're going to do 1 plus your rate as a decimal. And that's why we just did that percent in decimal work. Because again, we have to take that percentage, change it into a decimal and add it to 1, and then there is our multiplier. Dun, dun, dun. So our actual rate formula is kind of what you see here, this 1 plus r, except it's going to be 1 plus or minus r to give us our multiplier. And we say plus or minus because we will, when we're in that decay tomorrow, we do 1 minus our rate. But because we're talking about growth today, we're doing that 1 plus our r value. Okay, so we're going to just quick do some practice with that. So we have an increase of 9%. So again, I'm going to take that percent, I'm going to change it into a decimal and add it to 1. So to change 9% into a decimal, I move it twice. So we'd say 0.09 is it as a decimal. So we're going to do 1 plus my rate as a decimal, and there's my multiplier. So again, we change the percent to a decimal, and then do 1 plus that. Remember, when we're moving that decimal place, if we're going past however many numbers there are, so in here, like, we were moving it 2, but 9 was the only number we had, we keep going, and we put a 0 in its space. Here, for 75%, we're going to move that decimal twice, and it comes right out on the end. So now again, we do 1 plus our rate, and we get 1.75. That would be my multiplier. And then again, on this one, move it twice, once, twice, and again, when we move farther than there are digits, we just fill it in with a 0. So we get 0.009. and we do 1 plus that to get our rate, our multiplier, excuse me. So again, to find your multiplier, percent to a decimal, add 1 to it. Go ahead and take a second and try these 6, and then unpause me when you're ready. Alright, there's the answers. See how you did. Fix any you got wrong. So again, on each, we're moving that decimal place over twice. And then if you're moving past however many digits you have, we're filling them in with a 0, and then adding it to 1. Now, these multipliers in this exponential growth that we're talking about can be used when we're like shopping at a store or when we're at a restaurant trying to figure out what my bill would be with a tip. So for a decrease or a decay, what we'll talk about tomorrow, you can use this to find out what the discounted price of an item is at a store. So if your shoes were $50 and it's 30% off, we multiply that 50 by 0.7, and that would give us our sale price, $35. And that 0.7 comes from, remember I said a decay is 1 minus R, so it would be 1 minus 0.3, which gives us 0.7. And for an increase, what we're talking about today, think of restaurants, right? An average percent for a tip is 15 to 20% that you would serve you would give your waitress. So let's say your meal costed $35 and you had a really great meal, so you want to tip them 20% and give them a good tip. You would multiply your total cost by your multiplier. So that rate, 0.2 plus 1, 1.2, and then you would get your total amount that you would want to write on your bill, $42. All right. I'm going to work through this problem as an example, and then you'll have 6 problems to try, 5 problems to try, and then I'll show you the answers and kind of talk through them. But let's work through this one first. So we have, over the past 20 years, the population of the United States has increased by 1.2%. The most recent U.S. Census done found that there were 310 million people living here. How much is the population increasing each year? Well, 1.2%. And I say, how do we turn this into a growth factor? Or how do we turn this into a multiplier? And we just practiced doing that. So I'm going to take that 1.2% and I'm going to move that decimal place over, and we get 0.012. And I'm going to add that to 1. And now we have our multiplier. So again, to find your multiplier, we take that percentage, move the decimal over twice, add it to 1. So now we have our B value. So we can do C, write an equation that would model this situation. So we're going to write the exponential equation. We have y equals, how many people did we start with? 310 million people. So I'm going to just write 310 and understand that we're doing this in millions of people. My multiplier was 1.012 to the x. So now we can use this to figure out what our population is going to be after, 1 year later, after 2 years later, 3 years later, 4 years later. So with 0 representing the year 2010, our initial year, create a table for 2010 to 2015. I'm going to say X, and I'm going to say Y. Okay, so what's important to remember is you guys practice this. We have a table here. 310 is my A value. That's my starting point. So we're going to start with 310. Oh my goodness, maybe. Million people. goodness. It would help if my pen was letting me write. And again, that's at time 0 when we started. And now I'm going to make my next couple of years. So we have 2010, 2011, 12, 13, 14, and 2015. So we made it starting with our initial value, and now we can go ahead and use that multiplier. So again, this is my multiplier for increasing by 1.2%. So we're going to multiply by 1. Goodness gracious. Sorry, this is being weird. Multiply by 1.012. And we're going to do that each time as we work through down the table. So in my calculator here, I'm going to do 310 times 1.012. And we get 300, and I'll round up to 14. And I'm just going to go down my table and multiplying by about 1.012. Alright, and so there's our table. I just didn't want to waste the time. So again, we took 310, multiplied it by our multiplier, 314, multiplied by our multiplier, and so on, all the way down. So by 2015, 5 years later, we have 329 million people. For sketching a graph of this situation, so we have our years down here as we're going through time, and this is obviously our population. Now, looking at this, we are starting at 310. So I want to start my graph not here at my intersection, because this represents 0. I'm not starting at a population of 0. I'm starting with a population of 310. So I am going to start above my x-axis to show that we're starting with something. If I drew a line starting from here, that means we're starting with 0. So this is the wrong line. We want to start above that intersection because we are starting with a specific amount. And then lastly, what was the estimated amount in 2020? So we started in 2010, now we're 2020, so how many years later is that? That's 10 years later. So we're going to take that 10 and plug it into our equation. So 310, 1.012 to 10 years, and we'll see what we get. So we're going to take, remember, exponents first, so I'm going to do 1.012, the little XY button to give my caret, and I'm going to say 10 years. And now we're going to take that number and multiply it by that 310 we had out front. So now we're at 349. And again, that's in millions. So after 10 years, we're going to jump from 310 million people to 349 million people. Key things, again, to get our multiplier, okay? We are taking our percentage, moving that decimal place twice to the left, adding it to 1. To figure out what you would have after so many days, years, hours, we take that number, plug it in for x, exponents first. So you're going to do this. You have give the multiplier that would be used to triple, increase by 75, increase by 4.5. And then you have 4 problems to solve. The first one is like the top one, where you're going to create your equation. So make sure you make this into that multiplier, just how we did in A here. And then you're going to solve for 6 years. Here, I want you to try explaining to me what that multiplier means. And then again, 4 is similar to 2. And then 5 is similar to 3. Give it your best shot, check your answers on the answer key, and let me know if you need help.